Is there a colony genotype? We've talked about individuals have genotypes, and the genotype and the environment make the phenotype. But is there a colony genotype? We don't really have one that's under selection, like one individual whose genes are under selection. We have a collection of them. We can think about that in a broader term, in a sense, in that when you look at larval development, there I think we see a colony genotype. We see the coordinated effort of adult worker bees and larvae. They're working together. So there's genes in the larvae that signal to the adult workers, their stage of development, their need for food. So they're basically giving them signals that say, feed me. And I'm this age, and so then the worker changes the kind of food, the nurse bee changes the kind of food that it feeds to larvae of different ages. So there's a talking to each other that evolves. So to get the right amount of food and the right sugar concentration to the larvae for them to develop into the right kind of phenotype, there has to be this dual talking between them. Honeybee nurse bees feed a different kind of program to queens versus workers. The queen diet is one that's high in sugar early in life, fed ad lib, and it's throughout its life, it gets basically the same kind of food fed to it. This leads to the developmental process to turn it into a phenotype like this that has lots of ovarials in their ovaries. The worker diet for the first nearly four larval instars gets fed food of lower quality with respect to sugar, low sugar, and then after the beginning in the fifth larval instar, they get higher concentration of sugar, but they don't get fed very much. So they have a different feeding program, and that's what makes the difference between a queen and a worker. These programs are different. They evolved over many thousands of generations, millions of generations. They evolved so that the right food complement, the right dietary program is fed to the queen to get a queen and the worker to get a worker. But the larvae had to respond because the larvae are the ones that are developing. They're the ones that are turning into a queen or a worker. So they're getting signals, and then the genes and the coordinated networks of genes that turn into a queen or a worker are activated. We did an experiment that shows how this can work. We have our low-strain bees and our high-strain bees. So our low-strain bees, if you recall, have ovaries that are smaller than the ovaries of the high-strain bees. So we did what's called a cross-fostering experiment. So if you take a larva from a low strain and you let low strain nurses raise that larva, you get ovaries that are like this. If you take a high strain bee and a larva and you have it raised by nurse bees of a high strain colony, they end up like this. They're bigger. But what happens if you take a high strain larva and you let low strain nurse bees feed it? Now the signal, we selected these colonies, and the signals between the larvae and the nurse bees evolved together to give the right phenotype that was needed to produce this genotype, the amount of pollen stored in the comb. So it happens that if you let a low strain nurse bees and a low strain colony raise high strain larvae, they end up with ovaries that are significantly bigger than they are when their own nurse bees raise them. If you take a low strain larva and you let high strain nurse bees raise it, you end up with an ovary phenotype that's actually smaller than when they are raised by their own low strain bees.